whenever an input image is given to our machine, its task is to answer the question related to that image. So there are 4 steps in this. First step is image featureization. That is, we need to cater all the features of the image. We have seen that CNN, convolutional neural network, is the best to be used when we have the input as an image. So for image featureization also, we are going to use a convolutional neural network. Convolutional neural network, they have become the gold standard for the pattern recognition in the images. After an input image is passed through the convolutional network, it gets transformed into its abstract feature representation. That means the image will be inputted into our convolutional network, and that convolutional neural network, it will abstract the main features from it. Each filter in the convolutional neural network layer, it will capture the different kinds of patterns like the edges, the vertices, the contours, the curves and symmetrics that we have in the image. That means CNN can perform the function of image featureization. Because what it will do, whenever the input image is passed through our CNN, it will be transformed into its feature representation. We have various filters in our convolutional neural network. So they will capture the different kinds of patterns like the vertices, the edges, the curves, the contours, the symmetries of all the objects that we have in the image. So CNN, they have evolved as the most complicated architecture which are used for the downstream task, like for the classification, for image detection, for image segmentation, like we have seen previously that if an image is provided to us, so there can be a number of things that can be performed on that. Like we can have the image classification, we can have the object detection, we can have the image segmentation, we can have the spatial relationship between the objects. So number of questions related to the image can be asked. So for all this, CNN provides us the best architecture. Some such networks include like LXNet we have, ResNet that we have, LeNet, SqueezeNet, VGGNet and ZFNet. So there are many networks which are formed on the basis of this, which can extract all the features of the image. Why is this image featureization important? This is important because we want our neural network, we want our machine to understand what all do we have in the image, what all features the image have. It is not so easy for the machine, for the neural network as it is for us. Whenever we see an image, what happens? We can easily recognize the objects that we have. We can so easily find out that what is where in this particular image. But performing the same task by the machine takes a lot of effort for building such a machine. There are neural networks which are specifically designed for the purpose that the image can be retrieved in a very well way. So for that, convolutional neural network plays a very important role, we can say, in understanding the various patterns, the various things like we have the curves of the image, we have the symmetries in the image, we have the edges, vertices, whatever we have in the image. So CNN can understand all this easily. So next, after image featureization, if we want to perform the task of visual question answering, what is the next task that we need to perform? That is the question featureization. Question featureization, what we are trying to do? We are trying to, if we have certain questions, they have to be represented into some mathematical form. This is called embedding of the words. That means whatever questions which can be asked related to the image, they have to be embedded in a proper form. So there are several methods to create the embeddings. Embedding means converting the words, the text we can say, into some mathematical form. So we have various methods to create such embeddings. Earlier we have some older approaches which included count based, frequency based methods, like we can say count vectorization, TF-IDF. These were the methods that we were earlier using for the purpose of question featureization. There are predictions based methods like continuous bag of words and skipgrams as well. So these are few methods for which we are using for the purpose of word embedding. Word embedding is the task of converting the text into some mathematical form which a neural network can understand. Pre-trained training models for the word-to-vec algorithm, they are also available in the open source code, like we have GenSim. We have deep learning architectures like RNN, like 1D CNN. They can also be used for the purpose of word embedding. If we talk about the visual question answer literature, LSTM that we studied, that was the long short term memory. It was the most frequently used for the purpose of word embedding. So we have various models for the word to vector algorithms. There are few algorithms which are being designed for the purpose of word embedding. Whenever we want to do the word embedding, that means whatever we are doing here, question featureization, that means some text is being provided to our neural network and this text has to be converted into some form of mathematical form that a neural network it can understand. So for this, we use different type of deep neural networks, like we can use RNN, we studied, that was recurrent neural network, GRU, the gated recurrent unit, then we studied about CNN, that was convolutional neural network, and among these, LSTM, that we talked about earlier, that was long short term memory, is the most frequently used for the purpose of question featureization. So whenever we are doing visual question answering, the first step that we do is image featureization. That means extracting all the features from the image. Second is the question featureization. Question featureization means what? Doing the word embedding, converting the text into some mathematical forms that a neural network can understand. And what all neural network we are using here? We can use CNN, we can use RNN, we can use GRU, and the most frequent one is the LSTM that we normally use for the purpose of question featureization. Our third step will now be joint feature representation. That means we have performed two steps, image featureization and question featureization. So now we are on to the third step, which is joint feature representation. One of the common ways of handling the different feature vectors that are coming from the images and the text is by concatenating the two. Concatenating means combining these two and letting the later layers find the weight for each. That means what we are trying to do? We are trying to perform the function of visual question answering. So for that, what we need to do? We have to make sure that what image can it be? What all is being represented in the image? And what questions related to it can be asked? So the most common ways to handle is to one of the common ways of handling the different feature vectors that are coming from the images and text. It is by concatenating these two and letting the later layers, since we have number of layers in our neural network. So now the later layers, they will find out the right weight for each. We can also try element wise addition, multiplication if the future vectors, they are of the same length. So that means what we are trying to do now here in joint feature representation, we are combining the above two steps, and accordingly we will design the weights. The weights that are being multiplied with the inputs, and after that the computation process is being done and we will receive our out. So now the fourth step that we have will be the answer generation that we want. We want that some image we input into our neural network and it should answer our questions. So the research on visual question answering, it includes a free form open-ended question where our answer could be in words, in phrases, or even in the complete sentences. So we want answer generation from our neural network, from our machine that we are doing. Whenever we are performing this deep learning, we want our neural network to answer the questions related to the image when we are performing the task of visual question answering. So what questions can it be asked and what form in the answer could be? It can be free form, open-ended question, and the answer could be in few words, in phrases, or even in the complete sentences. Then object counting. We can do object counting questions where our task will be counting the number of objects in the image. So that can be the question. Another one, multiple choice questions can be given, means various choices will be given, and from that the our visual question answering, this processor, it will choose the correct answer. Then there can be even binary questions. Binary question means where the answer is in the form of yes or no. That means any form of answer generation we can expect from our neural network. So till now we have seen that when we are performing the task of visual question answering, we are going to be this is going to be processed in four major steps. One is the image featureization, second is the question featureization, third is the joint feature representation, and the fourth one is the answer generation. So this was about visual question answering. Now this another term that you might hear when we are talking about our deep learning concepts, that is visual dialogue. The term is visual dialogue. Visual dialogue, it will require an AI agent to hold a meaningful dialogue with the human in natural conversational language. We want our artificial intelligent agent. Every time the entity that performs our task, that will be represented by an agent. So in visual dialogue, what do we require? We require an artificial intelligent agent to hold a meaningful dialogue with the humans in the natural conversational language that we normally use about any visual content. Since we are talking about visual dialogue, that means any visual content will be provided and it will answer the question in the normal conversational language. Specifically, given an image, a dialogue history, and a question about the image, the agent, it has to ground the question in the image, infer the context from the history, and answer the question accurately. That means our system, it will be provided with an image, a dialogue history related to it, any question about the image. So agent has to ground that question in the image and infer context from the history and answer our question accurately. That is what we want in case of visual dialogue. So visual dialogue, it is disentangled in a form of a specific downstream task so as to ensure that general test of machine intelligence. Here, computer vision, it allows the object evaluation by sending some responses and by doing the benchmark progress. That means in visual dialogue, we are even making use of our computer vision task. We have a system which like we have vision. We can see something with our vision. Similarly, we have designed computer vision task. That means we want our system, our neural network to also analyze whatever is being represented to it. So that is a computer vision task. Specifically given an image dialogue history and a followed question about the image. The task here is to answer the question. So that is visual dialogue. What does visual dialogue means? Visual dialogue means our AI agent, it holds a meaningful dialogue with humans in the natural conversational language about any visual content. That means visual content means we are providing anything which can be seen, anything. We are not providing it with the text, we are providing it with a visual thing. That means any image related to image, the question can be asked and our AI agent should be able to answer the question in the natural conversational language that we humans normally do. When we see a particular photograph, we can talk about it in our general language. So that is what we want from our AI agent too. So that is called visual dialogue.